So we've spent a lot of time talking about linear equations, linear systems. We're going to talk about something that's sort of related, but linear inequalities, okay? We've been dealing mainly with linear equations. So early in the semester, we dealt with linear equalities in one variable. So for example, x is greater than equal to 5. So we represent that on a number line. It's all the numbers that are 5 or greater, okay? The other thing we did, we represented this in interval notation, so it's 5 to infinity, including the 5. So two ways to represent our solution to that. Now, when we look at a linear equation in two variables, like y equals x plus 5, so if I graph this, I go to 5, the slope is 1. So there are infinitely many solutions to this equation. Graphically, I can see those solutions by just looking at the line. So if I insert the line right there, this is the line y equals x plus 5, but it's also a graphical representation of the infinite number of solutions to that equation. Now, what would it mean if I said y is greater than equal to 5? Well, it would mean this one is the set of all, this is the set of all y values that are equal to x plus 5. So you give me an x, I'll add 5 to it and tell you what y is. This one over here on the right says the set of all y values that are greater than x plus 5. So if you add 5 to any number, I want a y value that is larger than or equal to that. So what we're going to do, we're going to graph the same line, like so. So if I graph my line again, like so. So this is the line y equals x plus 5. So every point on that line, the y value is exactly equal to x plus 5. Let's pick a point like right here. If I pick this point right here, negative 5, 5, is the y value greater than equal to x plus 5? So if you look at x and x plus 5, so if I substitute in a negative 5, I get negative 5 plus 5 is equal to 5. So the question is, the y value there is 5. So is 5 greater than equal to 5? The answer is yes. So this would be a solution to the inequality. Let's pick another point. Let's pick the point 0, 0. So I'm asking myself, I'm looking at y is greater than equal to 0, excuse me, y is greater than equal to x plus 5. Let's substitute a 0 for y and a 0 for x. And then I'm asking myself, is 0 greater than equal to 5? The answer is no. So this is not part of the solution. So the solution to y is greater than equal to 5 are going to be all of these points here. So the line is included, and all of these points above the line would be part of the solution. Okay? So I'm saying all the y values that are greater than or equal to x plus 5. So the way I think of this is, where are the y values on the graph that are greater than the y values on the line? So the y values that are greater would be above. So anything above that line would have a y value that's greater than x plus 5. So the other way, like I said, you can do it, you can just pick test points, what we did there. So like I picked the test point 0, 0, and then I asked myself, is 0, 0, is 0 greater than 0 plus 5? The answer is no. That means that 0, 0 is not part of your solution. So you did not shade below this line. If I pick a point that's above the line, let's pick, say, like 0, 10. Is 10 greater than or equal to 0 plus 5? The answer is yes. So 0, 10 is part of my solution, which reinforces that I'll be shading above that line. Let's look at an example here. Graph the solution to this inequality. Y is less than or equal to negative 2x plus 5. The first thing I have to graph is 2x plus 5. It's going to be negative 2x plus 5. So slope is negative 2. So I would draw that line. As long as this thing has been solved for positive y, you can just read the inequality. Less than negative 2x plus 5. Everything on the line is where y equals. So everything on the line is where y equals negative 2x plus 5. If I say y is less than, then what I mean is I want to shade below this line. So this is my solution to this inequality. Now if I look at the next one, the only thing that changed, instead of less than or equal to, it's less than negative 2x plus 5. So I'm going to graph the same line, 5. The slope is negative 2. So I'm going to graph this line. So I'll graph the line just like I did a moment ago. But here's a big difference. The way I do this is when I see that it is less than or equal, less than, so what I need to do is just make this a dotted line. So it's a dotted line, and that indicates for me that the line is not included. So the one on the left, it includes the line. The one on the left includes the line. The one on the right does not include the line, and I'm still shading below. So my solution is everything below this line, but not including the line. Okay, so that's one of the big differences in making sure you're looking at when there's an equal to versus there's a less than. I can verify this. One of the easy points to always pick if your line doesn't go through it is 0, 0. So let's just verify this. If I pick 0, 0, the question becomes, is 0 less than or equal to 0 plus 5? The answer is yes. That means that 0, 0 is part of your solution, and I see that. Okay. If I look at the next one, same thing, 0, 0 is 0, and this one should just be, instead of less than or equal to, this is strictly less than. Is 0 less than negative 0 plus 5? Answer is yes. 0, 0 is part of that solution. Let's look at another example. Negative y is less than 3x. So negative y is less than or equal to 3x. And then over here, I'm going to have 1 minus y less than 2/3 x plus 5. Okay, so if I graph this line, graph the line negative y equals 3x. That's the same as the line y equals negative 3x. So y equals negative 3x, it goes through the origin. Slope is negative 3. So less than or equal to, this is a solid line. It's always a good thing to determine up front, because if you wait until after you've graphed it, then sometimes we forget, should it be solid or should it be dotted? So it's a solid line. Okay. Now I cannot pick 0, 0 as one of my test points because it lies on the line. So let's just try the point 1, 1. And I substitute into this formula 1, 1. Is negative 1 less than or equal to 3 times negative 1? So is negative 1 less than or equal to negative 3? So the question is -1 less than or equal to -3? The answer is no. So what it means here is that 1, 1 is not part of the solution. Sorry, back up on that mistake here. This was a 1, not a -1. So the question was, is -1 less than or equal to 3? Is -1 less than or equal to 3? The answer is yes. So that tells me if -1 is less than 3, then I get a true statement. This point is part of my solution. So here is my solution here. Now this one feels different because it was a less than, but I'm shading above the line. The way you could have eliminated that is I could take this inequality, multiply both sides by -1, and you get y is greater than equal to -3x. So if I've solved for positive y, I could just look at the inequality and say, oh, I'm shading above that line. Okay. If I look at the next one, what line do I need to graph? I need to graph y equals 2/3 x. So it's negative y equals 2/3 x. If I subtract that 1, so +4, or y equals -2/3 x minus 4. That's the line that I need to graph. So at -4, and the slope is -2/3. So 2, 3, 2, 3, 2, 3, 2, 3, and up 2/3, so forth. So if I insert that line, like so, and this one is strictly less than, so this is going to be a dotted line. And so if I pick a test point, like 0, 0, and I look at this original equation, 1 minus 0 is going to be 1 is less than 0 plus 5. That's true. So 0, 0 is a part of my solution. So even though it was less than, I'm shading above the line. I could have solved this right away. When I get to here, I could have said, okay, let's add the y to both sides. So 1 is less than 2/3 x plus 5 plus y. If I subtract the 2/3 from both sides, subtract the 5, so you've got y is greater than -2/3 x minus 4. So once I've solved for positive y, then I know that the greater than means I shade above. This one had a negative y, so the less than doesn't mean shade below. So it needs to be solved for the positive value, if you can determine that. Let's look at this example. The Science Club sells t-shirts and keychains to raise money. T-shirts are $15 each. So what have I got going on here? I've got t-shirts. So t-shirts at $15 each, and I've got keychains at $5 each. Okay. And my goal is to make at least $750. Okay. Graph the solution that shows how many they should sell. Will they meet their goal if they sell 40 shirts and 60 keychains? So let me make this grid a little bit smaller so I can fit everything on it. That should work. So to make at least 750, so that means I could make 750, I could make 800, but I can't make 700. So at least 750 means something is going to be greater than equal to 750. So that's what it means to be at least 750. Let's let x equal the number of t-shirts and y equal the number of keychains. Then I know that 15x plus 5y has to be greater than equal to 750. So let's graph the line that's 15x plus 5y equals 750. So if x is 0, then 5y equals 750. So that's going to be 150. If y is 0, 15 goes into 75. That's going to be 50 times. So these are my intercepts. So your x represents t-shirts on your x-axis, and then your y value is what? Keychains. So I need to be able to scale on the y from 0 up to 150. So if I do something like this, 50, 100, 150, and I need to be a scale over to 50, so 10, 20, 30, 40, that wouldn't do it. So if I do something like, I'll do, say, 25 and 50. Okay, so the point is 0, 150 right here. And the other point is 50, 0, which is right here. And because it's greater than or equal to, it's going to be a solid line. Now I just want to be sure where I'm shading for this particular one. If I were to plug in the point 0, 0, is 0 greater than or equal to 750? Answer is no. So 0, 0 is not part of the solution. So my solution is all of this. Then the other question that remains was, will I meet my goal if I sell 40 shirts and 60 keychains? So 40 shirts, so 25, 30, 35, 40. So 40 is right here, and 60 is right here. So 40, 60 is the point right there. So that point is part of my solution. The way I can verify it, I can plug in a 40 and a 60. So 4 times 15, this is going to be what, 600 plus 30. 5 times 60 is going to be 300. That's going to give me 900, which is greater than 750. So I see that will they meet their goal doing this? Yes. Okay. And that leads you up, oh no, got a couple more problems. Is negative 3, 4 a solution to this inequality? All you have to do is just plug into C. So if I look at this, 2 times negative 3 minus 3 times 4 is less than negative 2. Negative 6 minus 12 less than negative 2. Negative 18 less than negative 2. That is true. Okay. So the answer is yes. Give the equation of the inequality. So I need to figure out what this line is. It looks like on this line, b is equal to 7, and it appears that the slope is what, 2, and this is 3. So m equals negative 2/3, and I'm shading above the line, so it's going to be y is greater than negative 2/3 x plus 7. The next one's going to have a solid line, so it's going to be including an equal sign. So if I look at this one, b is equal to 4, and it appears that the slope is what, 2/3. So the line is y equals 2/3 x plus 4. I'm shading above that line, and it's a solid line, so greater than equal to. Looking at the next one, it looks like b is equal to 4. And let's see about my slope. It looks like the slope is 2/5. Okay, or excuse me, negative 2/5. So I'm shading below that line, negative 2/5 x plus 4. And so that would be less than. The next one, it looks like b is equal to negative 3. And the slope is 3/5. Or let's see. Looks like the slope is, oh wait, back up. That would be 3/6 or 1/2. So the slope is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. So slope is 1/2. And so this is y equals 1/2 x minus 3. And I'm shading below that line, and it's a solid line. And that, well, I keep saying that leads to the homework, but we've got 2 more problems. Write an inequality for which 3, 7, and negative 2, 3 are solutions. So 3, 7, and negative 2, 3. Okay. Now, there's a difference between them. One says write an inequality, one says write it in 2 variables. There's many ways to do this. This is the line, what is this, y equals 0? Okay, so those two have y values that are above, so one way I can say it, y is greater than 0. That inequality will work. Negative 2, 3 and 3, 7 work for this guy. And you could also do something like, this is the line x equal 10. So you could say x is less than or equal to 10. That would work. Write an inequality in 2 variables. So now those were in 1 variable. So same points, 3, 7. So 3, 7 and negative 2, 3. So I need a line that these things are both solutions to. So if I were to graph something like this line right here, this is the line y equals x, okay? It's clear that both of those points are above the line. So I could say y is greater than x, and both of those are solutions. There are many different answers here. All I would need is a line that both these points live above. What would not work is this line would not work, okay? Because both of those points would not be solutions, okay? And that leads us up into homework for this section.